Hey Finxters, and welcome to this short video about Python's built-in divmod function. And this is a very short guide. I will show you that a very little known Python function. It's called divmod. It takes two arguments, two numerical values a and b, and it calculates the integer division. So it returns a tuple of two values. The first value of the return tuple is the result of the integer division of a divided by b, so the two input arguments, and the second value of the tuple is the result of the modulo operation on a and b. So basically, if you maybe let's have an example. So let's refresh this. Say we have, let's open an interactive share. So say you have two values, 10 and 4, for example. Now you can calculate divmod 10 and 4, and it returns 2 and 2. So what does it mean? It means that you can the result of the integer division of 10 divided by 4 is 2. So basically, if you have 10 integer division by 4 is 2, and 10 modulo 4 is 2 as well. Okay, so it calculates the remainder, the result of the integer division, so division without remainder, and then division with so basically the remainder. So if you calculate x times the result of the division without remainder plus the remainder, then you obtain the original value x, so the first input argument. So for example, if you have, let's have a few more examples. If you have 10 divided by 1, for example, now let's have divmod 10 and 1. Now we can calculate 10 divided by 1 is 10 without remainder. So the result of the integer division is 10. So the first tuple value will be 10. The second one will be 0 because there won't be any remainder. Okay, so we have 10 and 0. If you calculate divmod 10 and 2, for example, now what would be the result? Yeah, correctly, it's 5 and 0. If you have divmod 3, now it becomes a bit more interested. Divmod 10 and 3. Interesting. So we have 3 fits into 10 3 times, and we have remainder 1. So 3 and 1 is the remainder, and so on. Okay, and you can also use it on float values. It works just the same way on float values, basically. Just using like the respective float computation. So this is a very interesting function. Many people don't know it, and actually I have. So what would be if you would create your own divmod function, it would look like this. So divmod own, it takes two values, x and y, and now it returns, say, a tuple. So we have a tuple of values, and now it returns two values. The first value being the result of x divided by y, integer division, and x modulo y. So this would work for two integer inputs. We just ignore the float inputs for now. Okay, so and now we can calculate divmod own on 10 and 2, say 10 and 3, and we obtain the same result. So 10 and 3 result is 3, 1. So it fits 3 times, so 3 times 3 is 9, plus 1 is 10. Okay, so this way you can calculate your own divmod function, and basically it's a bit more. So divmod is equivalent to this operation where you first perform integer computation and then you perform modulo computation on the two operands. And this is very, very useful for many instances. And there's one big advantage: the divmod function is faster than using this computation. Why is that? So the reason is simple. In this case, you perform integer division of these two values, and in this case you perform integer division to calculate the remainder, the modulo operation. So the modulo operation internally kind of uses integer division, so it uses many of the same computations that are already needed for the integer division. It has to perform the same computations again, so we have redundant computations. So therefore I have done some measurements. You can check the result of those measurements in my article here. So you see here on the left, we have the elapsed runtime for like 10 million divmod operations. It's 8% faster than the elapsed runtime for this integer division combined with modulo operation, because we have some redundancy in the code. So it's only a small detail, but I think the divmod function is quite useful to know because it's faster, it's very concise, and it calculates both. So it calculates the division without remainder and the remainder in one coherent function, and it's built in, so you don't have to import any library for this. Okay, thanks for watching this video. If you want to check out more free Python educational stuff, then check out our free email academy in the description below, where we introduce the most important Python functions in cheat sheets and NumPy introduction, machine learning introduction, all of those mini courses in our email series. So it's free, you can check it out. And yeah, thanks for watching this video. See you in the next video. Bye.